and welcome back to Unit 7, Day 5. This is example problem 2. So example problem 2, just so you know, uses the same equation, chemical reaction equation from example problem 1. So step 1, which is balancing the chemical equation, has already been done. RC already found the molar mass of NH3, so I wrote that information down. Okay, so in this problem, we're given the moles of N2 and the moles of H2. And they're asking what's our limiting reactant and then how much NH3 our product can be produced, which again, that's our theoretical yield is what they're asking us for. And then what is the percent yield if you isolated 8.62 grams of NH3. So what we need to do is we need to figure out the amount of NH3 that can be made from each reactant. So how much NH3 can be made from 1.42 moles of N2, and then how much NH3 can be made from 0.8 moles of H2. So I'm going to do this in the step-by-step method first, and then I'll do the one-line method. I'll link them separately. So when you do the step-by-step method, after I finish and we went over the theoretical yield and percent yield, you can go ahead and stop. And the one-step method version or one-line method will be linked separately. So it'll start where the one line starts. Okay, let's get started. So our process is, when we're converting from moles of N2 to the mass of NH3, is to follow this step, amount of given to moles of given. But luckily we were given the moles of our given. So we actually can start right here. We're starting right here, moles of given. So you're always going to be careful about what you're starting with and what you're ending with. The units are super important for all these stoichiometry problems. Okay, so we're technically on step 2. We can skip step 1. We're on step 2 where we're converting from mole of N2 to mole of NH3. And for this step, you're going to use the coefficients in the balanced chemical equation, okay? Where we know that 1 mole of N2 is equivalent to 2 moles of NH3. All right, so let's take our 1.4 mole of N2 over 1. That's what we're starting with here in this problem. And we're going to put the 1 mole of N2 on the bottom. Remember, this 1 mole comes from the coefficient, okay? And then the 2 mole of NH3 on top. Okay, and then our moles of N2 cancel out. So that's 1.4 times 2, which is just 2.8. I won't even bother putting that in the calculator. Okay, 2.8 moles of NH3. Now that we have the 2.8 moles of NH3, we're going to do the third step in this process. Okay, so we're here. We're going to go from the moles of our fine, so from moles of NH3 to mass of NH3. And for that, we have to use the molar mass, which I've written up here. So let's take our 2.8 moles, put it over 1. And then we want to get mass and cancel out the moles of NH3. So the 1 mole of NH3 goes on the bottom to cancel those out. And then the 17.04 grams NH3 goes on top. So we're just multiplying these two values. And you get 47.7. Which if we're using sig figs will be 48 grams of NH3. Okay. All right, cool. We're gonna do the same thing for H2, and we're starting with 0.8 moles. In the case of in the case of the conversion from H2 to NH3, these are the coefficients we're going to use. So we're going to put the 3 moles of H2 on the bottom, so moles of H2 cancel out. Remember, this 3 comes from the coefficient in the balanced chemical equation. And then the 2 moles of NH3 goes on top. And again, that comes from the coefficient of the balanced chemical equation. Whoosh, whoosh. All right, so now what we're going to do is 0.8 times 2 divided by 3. Oops. 0.53, which this only has 1 sig fig, so it's just 0.5. Of course, when as you're doing your work, when you're going from step to step, like until you get to your final answer, you actually don't need to round. It's always a good idea to keep an extra sig fig on so that you're not losing your precision, just so you know. So I could actually just put this as 0.53, even though that's not 1 sig fig. But that's because it's not my final answer. But when I get to my final answer, I have to use 1 sig fig if I'm using sig fig rules. All right, so mole of NH3 now to mass of NH3, and for that we're going to use our molar mass. So 0.53 mole NH3 over 1. And then I want to get rid of moles of NH3, so 1 mole of NH3, and then 17.04 grams of NH3. Okay, you multiply those. And then I get the mass to be 9.009, which is, again, I'm using 1 sig fig, so it'll be just 9 grams. Okay, so now we need to figure out what's our limiting reagent and what's our theoretical yield. As you can see here, the limiting reagent theoretical yield will be the one that gave you the smallest amount, right? So our limiting reagent will be H2 because it gives us the smallest amount of product. And then our theoretical yield will be 9 grams of NH3. Okay, so now that we have that done, what we're going to do now is we are going to take this information here. They are limiting. And I keep saying reagent. Reactant and reagent are the same thing. So my reactant is H2 because it gives the least amount of product, and the theoretical yield is 9 grams NH3. And then finally, for the percent yield, they told us that our actual, so what we actually got was 8.62 grams of NH3. But our theoretical is 9 grams, so divide those two, 8.62 divided by 9 times 100, and that's a 96% yield. Okay, it's not bad at all. Okay, cool. All right, so that's it if you're doing step-by-step method. Let's go on to, for those who are doing one line. So if you prefer the step-by-step method, you can stop now, you got your answer. All right, this video is starting for one line method. So for the one line method, put a line here. What we're gonna do is we are going to find the amount for of product that we can make from each reactant. So let's start, we're given 1.4 moles of N2. So we're gonna figure out how many grams of NH3 we can make from that. Oops, 1.4 mole N2 grams of NH3. Okay, so notice that in this case, we are starting with the moles of our given. So we're actually starting here. So that's pretty cool because we have less work to do. So we're going to take a 1.4 mole of N2. We already have our moles of given. So now we can convert it from moles of given to moles of find using the coefficients in the balanced chemical equation. So I have moles of N2 on top. I want moles of N2 on the bottom, and the coefficient is 1, so that would be 1 mole of N2. Remember, this 1 comes from the coefficient. All right, so then the top part will also come from the coefficient, and it will be for NH3, so 2 moles, because I'm trying to find NH3. Now I can convert from moles of NH3 to mass of NH3 by using the molar mass, which we found in the previous problem. So 1 mole NH3 goes on the bottom. And this one is not the same as that one. This one is from the fact that the molar mass is equivalent to 1 mole of the substance. So 1 mole of NH3 and then 17.04 grams of NH3 go on top. All right, so then we can go ahead and do our math here. Oops, 04. So this gives me, using sig figs, 48 grams of NH3. Now we're going to do the same thing. So we found for 1.4 moles of N2, we get 48 grams of NH3. We're going to do the same thing now for H2. So we're given, in this problem, 0.8 moles of H2. So we're starting here, moles of given to moles of fine. Use the coefficients in the balanced chemical equation. So we have 3 moles of H2 and 2 moles of NH3. 3 moles of H2 go on the bottom, so the 8 moles of H2 cancel out, and 2 moles of NH3 go on top. Now we have moles of fine, so we need to get the amount of fine, the mass, and that will be from the molar mass. And it should look the same as what you did up here, because we have the what we have now is the moles of NH3. So to cancel that out, we put 1 mole NH3 on the bottom, and then the mass 17.04 grams. All right, we do the math, put this in calculator, 0.8 times 2 times 17.04. So multiply everything in the top together, get an answer, and then divide that by what's in the bottom. So just, there's a 1 times 3 times 1, which is just 3, divided by 3 in the bottom, and then we get 9 grams of NH3 on there. So that means that, I didn't write this down, 0.8 mole H2, 2 grams of NH3. So that means that 0.8 moles of H2 will give you 9 grams of NH3. And so our limiting reactant will be the one that gives you the least amount, right? So our limiting reactant is H2 because it gives us the least amount of product. N2 gives us 42 grams, but H2 only gives us 9 grams, so that's our limiting. And the theoretical yield will be the 9 grams. To get the percent yield, you go to the amount that they tell you that you actually have. It says you isolated this amount, so that's what you actually have. You take that actual value, the actual yield, divide it by the theoretical yield, which you found in the previous step, and that gives you the percent yield. All right, that's it for this video. Have a quality day.